Continuing with the integration here, this time we're looking at the integral of e to the x. It's going to be pretty straightforward. Remember that previously you found the derivative of e to the x. This time we're going in reverse, finding the integral of e to the x. So we're just going to create two simple rules here. Now the integral of e to the x. Now I've been taking a shortcut here, and most of the time I just write integral of e to the x. We really should get in the habit of writing the integral of e to the x with respect to x. It's a little thing, but it's important that we're using that. You should remember that the derivative of e to the x is simply e to the x. That means the integral of e to the x is also going to be e to the x, but don't forget there's some sort of constant factor there as well. So the integral of e to the x dx, the integral of e to the x with respect to x is equal to e to the x plus c. Rule number one. So we'll go one step further here. Here's our second rule. The integral of e to the kx with respect to x. Now the k is just a constant, so it might be e to the 5x or e to the 10x or e to the 0.5x, whatever it might be. Now the integral of that's going to be equal to e to the kx, so pretty straightforward. That everything stays the same so far, but we're dividing the whole thing by k plus c. Just so that you don't get confused, there's also another interpretation of this rule. Same idea though. E to the kx times 1 on k. So 1 on k, e to the kx plus c. They're the same thing, obviously. So you can use this rule here, or you can use this rule here. Matter of personal preference. So here's our fairly straightforward worked example here. We have the integral of 3e to the 4x with respect to x. Now, the 3 might confuse you a little bit because it doesn't appear in either of our rules. Now, in any of these integration cases, if there's a constant that's multiplying, if the function is being multiplied by a constant, you can sort of ignore it out the front. This step is sort of optional. You can just jump to the next step if you feel confident enough. So now it says 3 times the integral of e to the 4x. Now applying our rule, that's going to be 3 times e to the kx, that's e to the 4x, over 4. That whole thing ends up looking like 3e to the 4x over 4. You might also see it expressed as, or 3/4 e to the 4x. They're both the same thing. So there's a fairly straightforward worked example. So let's try this one here. We have the integral of e to the negative 5x all over 4 with respect to x. Now this time we have this divide by 4 on the front, which might be freaking us out a little bit. This can be rewritten as 1/4 times e to the negative 5x, which can in turn be rewritten as 1/4 the integral of e to the negative 5x with respect to x. And now we have something that we can work with. So that's going to be 1/4 times, now it's going to be e to the negative 5x, that doesn't change, over whatever our k value was, so that's negative 5. So we have 1/4 times e to the negative 5x all over negative 5. You put all of that together, that 1 times that's just going to stay as it is, over 4 times negative 5, negative 20. Now, as has become customary for me, I've forgotten to add c's. Remember that when you're integrating, it's whatever the integral is plus some sort of constant. This was a mistake that I used to make in year 11 and 12, and it's a mistake I'll probably continue making. In terms of your exam preparation, make sure that you're doing this better than I am. I'll just run us through one final example here. I'll just get rid of our top worked example, and here's a third worked example we can look at. This is the integral of e to the x minus 1 all squared with respect to x. Now you may be tempted to look at this and think you're going to do some sort of reverse chain rule with it or something like that. Much better to expand it, and then work from there. So remember that this is the same as the integral of e to the x minus 1 times e to the x minus 1. So all of the thing in brackets squared, that means it multiplied by itself. And then you're going to have to expand those brackets using the FOIL method. E to the x times e to the x, that'll be e to the 2x. Now e to the x times negative 1 will be negative e to the x. E to the x times negative 1 will be negative e to the x. And negative 1 times negative 1 will be positive 1. Finally, e to the 2x minus 2e to the x plus 1. Now all of this should be with respect to x, with respect to x, with respect to x. Once we've finally done that, we can start integrating it. That's going to be e to the 2x over 2 minus 2e to the x. You can see there's just a 1 there, so divide it by 1, it's not going to change. Plus the integral of 1, which is 1x, or just plain old x. And of course, I'm not going to forget this time, a plus c on the end. So you can see that this exponential stuff, it can start off really easy with this kind of question, but pretty quickly we can start moving through into some more complicated stuff, something like that. So take your time, start with the easy ones, and start working your way forward.